Hello and welcome with another video. I'm your Professor Dr.Mchem from Dr.Mchem Institute of Chemistry, University of St. Jamshoro. I'm here with this new topic, that is strengths of Bronsted acids. Now, most of organic chemistry reactions are best followed and concluded by simply indulging into different strengths, of acids and bases, of acids and bases. Now, what that is the acids and bases that are taking part in a chemical reaction, So this all depends on Bronsted acids, that is this one. This all depends on the Bronsted acids strength, that how perfectly they could transfer protons to a Bronsted base or a standard to a Bronsted base, or you can call it a standard Bronsted base, which is mostly what? Of course, water, right? So this water, it is, it's a Bronsted base or a standard Bronsted base, and it is used as a standard base. Now the reaction I'm going to show you now below conveys how a proton transfer from an acid to a base, that is water, this one, takes place in a state of an equilibrium. Now here, as I've just said, Ha is an acid plus this base, that is water, in the equilibrium state. These are the arrows for the equilibrium. We are going to get, of course, this one, plus the formation of a hydronium ion. Here, what happens, that this hydronium ion, it resolves, whereas now its equilibrium constant would be what? K equilibrium equals to O plus upon, of course, this side is acid Ha in a bracket and water. So this is simply now the components in the brackets, that is this one, these are the components that are in brackets are concentration, molar, that is molar concentration. These are concentration or in moles or molar. So these components are that these ones, they are all in the ones that are in the brackets are simply in the equilibrium state. And so by multiplying this equation by water, that is in the brackets again, H2O, right? Now by getting this, a new constant Ka will be produced, a new constant. What is this Ka? This is called a dissociation constant. What we call it? Dissociation constant. So let's write the equation. So the equation is K equals to K equivalent and H2O equals to simply A negative and H3O, that is the hydronium ion, and the acid HA. After multiplying it, this would be like this. Now as every acid, it contributes its distinctive dissociation constant, right? So whenever the acid gets dissolved in water at some concentration, increased hydronium ions are formed. This is simply very easy, that whenever the acid gets dissolved, I'm writing this because this is a very important statement and it's supposed to be learned by the candidate who is going through this topic. Dissolved in water at some concentration, what happens after this? Increased, it will elevate or increase hydronium ions. It will simply increase the hydronium ions in the process. So we can say that its strength is calculated by its dissociation constant, right? Its strength is, how it's calculated? It's calculated is measured by its dissociation constant's magnitude, the magnitude it possesses. So now using P as a standard symbol, or for a negative logarithm, what you are going to write it down, it will be like that. pKa equals to minus log Ka, or simply pH equals to minus log the hydronium ion. Now this is presenting as acid strength in logs. What is this? This is presenting the acid strength in the logs or in logarithm. Always remember, as strong the acid is, as large its Ka would be. That is pKa, that is pKa equals to minus log Ka. Minus log Ka. Now what does this describes? It describes simply strong acids. That is, strong acids refers to small pK. That means what does this refers? It simply refers that strong acids they have what? Small pK. Small pKa. So this was a brief topic regarding the strengths of Bronsted acids, in which I explained you about some of the points regarding these strengths of different acids, and I have explained that most of these organic chemistry reactions are best followed, they are best learned and concluded by simply going into details into the by calculating the different strengths